Okay, here we are in part 2. I want to take the area bounded by y equals 1 minus x, the x-axis, and x equals 3, the area bounded by these three, and revolve it around the y-axis. Oh, we're going to, sorry, we already went around the y-axis, so we're going to revolve it around the x-axis. I want to show you a different shell problem. So there's the line 1 minus x, here's the x-axis, here's the line x equals 3. So we're looking at this area this time, and we're going to revolve it around the x-axis. So it doesn't have a hole in it this time. And we could do this with disks, and we did one similar, but I want to show you how to do it with the shell method as well. So we have a cone, sideways cone, once we revolve it. So we're going to fill this volume up with shells. So the shells are going to go the other way. So let's see. This shell, hard to draw. This is actually the bottom of the shell. So let me draw that a little better. Alright, so I'm going to take this will be the bottom of a shell, and it'll come up here and create a cylinder there. And then inside of that will be, and they always hook to the graphs that we are looking at. So the parts of the shell, it's very important to hook them to the graph. And then there's little bitty shells inside of this. And then up here we have some fatter shells. Alright, and once again my drawing ability is limiting this, but we're going to fill this up with shells inside of shells, or cylinders, open cylinders inside of open cylinders, until we fill up this whole volume. So let's set up the integral that'll help us do that. So I'm going to take the integral. This time the shells are going to stack. Since this was the line of interest down here, we're going to go from here to here. So we need to know that point. That point is where this line, which, let's take a peek at the name of the line again, 1 minus x, is connecting to the line x equals 3. So if I put 1 minus 3 here, I get minus 2. So my shells are going to stack inside of one another from minus 2 to 0. 2 pi r h, and this time the thickness of the side is between my two thumbs here, or this side. You can see it's a change in y. It's red over here on the y-axis. So we have a dy. The radius, it's kind of hard to find a shell I can draw here. I'll do the shell that is back here. This one showed up pretty good. The base of that shell, I can get the radius there. And I'm going to go down because the function of interest went down. So I'm going to look for this value. So that value is on the graph. Remember, to get there I went over x and down y. So x went over x then down y. So the radius is represented by y, but it went downward. So the radius is going to be negative y. That's going to take the place of the radius. And because if I want the radius to be a positive number, but if I grab just y, you can see that the y value right here, we went over x and down y, that y is a negative number. So I'm going to call it negative y to take care of that. Alright, and then h is going to be the height of the cylinder. So the cylinder's height is going to be from here to here. Alright, that's a little tricky because we know to get to this point we went over x and down y, and we know this value was x equals 3. So the height of the cylinder that I'm looking at is going to be the difference between whatever this point is and this point. Well, this point has an x value of 3, and this point, no matter where it is along this curve, has a value related to this point here. So we went over x and down y. So it's this over x part. So from here to here is our x value. And this from here to here is 3. If I bring this down. So I don't want this value, and I don't want this x equals 3 value. I want this height right here. So how do I get that if I know this whole distance from here to here is 3 and this distance is x? It is 3 minus x. So my height is 3 minus x dy. So I want to change x so that is in terms of y. I can do that with the formula. Y can be replaced with 1 minus x. So three minus, there's the 3 minus. When I get to x, I put in 1 minus y. I'm sorry, when I got to y, I put in 1 minus x. So I didn't do that right. When I got to x, I didn't do that right. I have to solve this for x. So I can put it in terms of y. So I need to get my eraser out. X equals, negative x will equal y minus 1. So I don't want to know what negative x equals. I want to know what positive x equals. So end up switching on 1 minus y. That looks better. And that's what I got earlier. So I'm working in y. So when I get to here, 3 minus x, I have solved the equation, and it becomes x is 1 minus y, which is what I wrote. So alright, 3 minus 1 minus y, and that is dy. So now I'm all in y, so I can simplify that and integrate it and multiply it by 2 pi. When I do all that, I get 8 pi over 3. So once I get the setup, I'm home free. Alright, so let's go ahead and gird our loins so that we'll be able to stand strong and work with volume byShells. That'll be up for our interest, and we come back from our break. I don't think we'll see it before that, but we'll be working those problems just like I did these. Alright, till we meet again, carry on.